Hey, GED students, let's look at three examples that look really different, but are basically the exact same, pretty simple algebra skill. So this is one of those great times when you can learn and practice one skill and have it get you a lot of points on the GED. And the skill in this case is called substitution. Let's take a look. First example says the expression W times 2W times the quantity of W minus 4 can be used to find the volume in cubic feet of a rectangular prism with a length that is twice its width and a height that is 4 feet less than its width. Evaluate the expression for W equals 9 to find the volume when the width is 9 feet. Now, this is a great example of how algebra actually makes your life easier, because this would be a really ugly word problem if they didn't already give you the directions. Like literally, they tell you exactly what to do so you don't even have to interpret the word problem. If you see that algebra, notice they said evaluate the expression. What expression? Well, the expression they gave you. They gave this expression to you already that finds the volume. They just want you to evaluate that expression. So the first really good habit I'm going to do, and I really, really, really want all my newbie students to always do this as their first step. No matter how obvious or easy it seems, write down your expression first. You guys will make less secretarial issues, less flipping of numbers, losing things if you just copy the expression down. And now you look at this and you go, Kate, I don't know what to do. W, like this is mean, this is horrible. You're trying to algebra me again and I can't stand it. Guys, we know what W is. Look what it says. It says evaluate the expression for W equals 9 to find the volume when the width is 9 feet. W is not some mystery you have to solve for. In fact, look at this expression, guys. If you didn't know what W was, you couldn't find it. Do you see how there's no equal sign? There's no information on the other side, like, I don't know, equals 43. There's no clue to help you to know what W would be. Without that, you couldn't solve for W if you wanted to, but it doesn't matter because you don't have to. You know what W is. It's 9. All you got to do is substitute it in. Now I'm going to pick a different color out just because I really want you to see this, because this time we have 3 W's. And you might say, well, one of them is 9. No, they're all 9. Every time you see the same letter, you're going to replace that W with a 9. So I'm going to have a 9 here for this W. And remember, with substitution, when you trade it out, you don't still have the W there, right? If I had a substitute teacher, I'd be gone and she'd be here. Same thing here. I substituted out W for 9. So the W is gone and the 9 is in. But I'm not going to lose anything else. It's only my variables that change. That's why they're called variables. So I'll still have my parentheses. I'll still have my 2. Now this looks a little tricky here because obviously this W is a 9, like we said, but what are the 2 and the 9 doing? Like, is that 29? And this is where this problem gets tricky. The 2 and the 9 are shoved together. And so I'm going to put them in parentheses to say 2 times 9. However, it would be really, really important to then close your parentheses over here. Now, it turns out on this expression, it doesn't matter, but on other ones it does. So I just want you to see these blue parentheses happen because I had parentheses here. But these green parentheses on the inside happened because W I replaced with 9, and I wanted to indicate that it was multiplying with 2. Okay, so that's a little tricky. Looks a little weird here. And now again, I see parentheses here in blue, so I'm going to still have parentheses, but my W is going to get replaced with 9. Now this one I don't need in parentheses because that W is not shoved against anything. It's not multiplying. I'll just have it like that. And from that, I want to subtract that 4. And take a look at that, my beginning students. This is usually a struggle for you. I need you to see how every green thing above was replaced with a green thing below. We included parentheses when that green thing was multiplying with something. And then every symbol from above that wasn't a variable. It wasn't a letter. The parentheses and the operations and the numbers, they are all still there in blue. Now, though, once you've substituted nicely, you can plug this entire expression into your TI. Anytime you do math like this on the GED, you get a calculator. So we're going to go ahead, we're going to plug into it, and I'm going to do it exactly the way I see it with the parentheses, okay? So 9, open up parentheses, 2, open up another parentheses. It's okay, I promise. 9, and then I got to make sure I close twice, just like I saw in my expression. A lot of students get all muddled when they're doing the calculator on the computer here. This is one of the reasons why it's great to have a handheld, because you can literally hold your handheld calculator right up to that screen to make sure you're getting all the symbols, because losing symbols is a big issue for struggling students. I'm going to open up another parentheses and do 9 minus, I almost hit negative, 4, close parentheses, enter, and I see that I get 810. Lovely. So this, the way we just did it, we did the substitution ourselves, and then we were so lazy that we simplified in our calculator. And I really do this skill of substitution by hand because it's not as bad as it looks, and it's a crucial one to algebra. So if there's any chance that you're going on to college and might need to take some algebra classes in college, like college algebra, having that skill of substitution, like a second nature, is super important. But I will admit, you don't actually have to know how to do this for the GED. Your calculator can do substitution for you. And if you're like, I got to test in a hurry, Kate, there's very little chance that I'm going on to college anytime soon. Please just let me pass the GED test. Well, I'll show you a trick. I feel kind of guilty, but let's take a look. All right, so here's the trick. When you have a known value in your calculator, like W equals 9, you can actually store that value in your calculator and then type the expression in and let your calculator substitute and simplify. But, and here's a big but, you don't, yeah, big but, math teacher humor. What was I saying? Oh, the trick is you don't have every letter. So come down here. I want you to see the variable button down at the bottom left of your screen. You don't need to press this in your calculator. I'm just trying to show it to you. It doesn't have every letter. Okay. I have X, Y, Z, T, A, B, and C. I'm able to store those letters. So you see, I have no W. Okay. If I press again, it just goes right back to X. And this guy has a W. So does that mean we cannot use this function if we have a W? Well, no, but we're just going to have to pick another letter. Just for the sake of it being lazy and easy, I think I'll do X. Okay, so what I'm going to do is I'm just going to treat this whole thing like there's X's so that I can use the lazy girl shortcut. Why not? The calculator doesn't know, like whatever, call it X, call it W, call it ugliest number I've ever heard of. So here's how we do it. First, we store the variable. So I'm going to take the number 9, type the number in that you know first, and then you type the little store button, which is right under the variable button. And then you type the variable button to store it as what you wanted. So I said I would store 9 as X. I press enter to communicate to the calculator that that's what I want to do. So first step, store the variable. And this is to evaluate in your TI. So what I'm saying when I say I'm going to evaluate in my TI, I'm saying I'm going to do the substitution and the simplifying in Calc. So first I'll store the variable by pressing the number, then the store button, which looks like that, and then enter. And now the second step is to type the expression with the variables now. You're not going to do the substitution, your calculator is. You're just communicating to your calculator what expression to substitute that stored value in. So your last step you just said to it was, every time you see X, I want you to put in 9. That's what you told your calculator when you said store. So we are going to type this entire expression up at the top with the variables in. X times 2X. Does your calculator know it's multiplying? Yes, it knows 2 shoved next to X is multiplying. Open up parentheses again, and then I'll type X minus 4. Close my parentheses, and there you can see I have that entire expression right there, exactly the way it appeared. And your calculator, when you press enter, boom, it did it for you, 810. So nice. We can substitute by hand, simplify in our calculator, or we can use the store key in our calculator to do both the substitution and the simplification for us. But just an FYI, you need that substitution skill for college, okay? If you have any plans to go into college. In this second example, evaluate a squared minus b squared for a equals -3 and b equals -1. I am going to beg you, please, 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 please use the GED calculator when there's negatives and exponents. Not because I don't think you guys can learn this, and in fact, you need to learn this for college, but just because you're going to be nervous. There's a lot to remember when you're testing, and this is the most common error. The most common error involves when we have negative values plugged into exponential expressions. So basically, you're putting a negative in with an exponent. And you guys make it again and again and again. It's like, doesn't matter how many videos I make about it, doesn't matter how much I write in the notes, highlight it, circle it, underline it, get you guys to tattoo it on your foreheads. Busy, stressed out students forget it and mess it up. Okay, so I'm going to do it in my calculator first this time, and then I'm going to do it by hand for you guys going to college. So let's just do it in our calculator, okay? This time we have two variables to store. We have a value for A and we have a value for B. We can store them both, but we have to do two stores to do it. Doesn't matter which one you start with, but I'll just type in -3 and then store. And then I can hit the variable button until I hit A and press enter. Okay, now every time your calculator sees A, it knows to substitute in -3. I will do the same thing with the B value, -1, store it in for B. And if you go past it by accident, guys, just keep clicking until you get to it again, okay? Don't stress out. Press enter there. Now I have both the values plugged in, and now I can do A squared minus B, there we go, squared, and see that it is 8. Pretty simple, okay? Now, we know it's going to be 8 when we use the store function on our calculator, and I want to show you what most students do wrong. What most students do wrong when they do the substitution themselves, and you'll encounter this in your college classes where you have to do the substitution yourself, is they just replace A with -3, put a square, and then they do minus, and they replace B with -1 and put a square, and then they type that in their calculator, -3 squared minus -1 squared. And you can see I didn't get the same answer. If it was good math, it should have given me the same answer, whether the calculator did the substitution or I did the substitution. So what did this student do wrong? And something super important they don't understand about exponents. Exponents are super duper weak. If I have this square on a negative number, the square is literally only working on the 3. That negative is not being squared. And same thing here. This square is literally only working on the 1. That negative in front is not being squared. Exponents are super duper weak. Now, you might say, well, why does it matter? It matters because of the original expression. Take a look back at the original expression. In the original expression, it says it wants you to square A. That means it wants you to square all of A. If you want to square all of a negative number, you've got to use parentheses to increase the strength of the exponent. So you're going to use parentheses. You'll tuck the -3 inside the parentheses and the square outside. And now that says square the whole thing, the number and the negative sign. Okay, and then I had a minus here, so I'll put a minus. And then again, this is a square on a -B value. And so I'll open up my parentheses, type -1 squared. And this is the thing that they know. They know you guys forget. In fact, I wouldn't be the least bit surprised if every evaluation example they gave you in the GED test had exponents and negatives. They're trying to trick those people who really just don't understand exponents, don't understand negatives, don't understand the order of operations. All right, but look what happens if I type it this way. So open up my parentheses this time, type the -3, close them, and then square it. And from that, I'll minus, open up my parentheses, type in the -1, close it, and square it. So same exact expression as above. The only difference there is the parentheses. And you can see this time I do get +8. And by the way, it doesn't necessarily have to be that it's +8 and -8, that they come out to the same number except a different sign. It could have been way off, very different. Oh, you guys, doing hard work. Let's do one more. In the equation y equals 2x minus 1, what is y when x equals 6? Now you could say to me, and I would agree with you if you did, Kate, this isn't an expression. This is an equation. Yeah, absolutely. This is an equation. We have an equal sign and we have an expression on either side. And you could say, well, Kate, you didn't teach me how to evaluate equations. You only taught me how to evaluate expressions. And I would say it's the same skill, you guys, same skill. So I'm going to start like I did before, y equals 2x minus 1. And I'm going to plug in what I know, and I'm going to use it to find what I don't know. So look what they're asking us to do. They're asking us, what is y? What is y? All right. When x is 6. So x is not a mystery. X is 6. So anywhere I see x, I can plug in with 6. Now notice that x and that 2 are shoved together, so they're multiplying. So I'm going to plug that 6 in using parentheses. I'll keep my 2, I'll keep my minus, I'll keep my 1, and keep my equals and my y. And look, might look a little different, but that's an expression on the right-hand side that has no variables in it anymore. There's no letters. And so I can just type it in my calculator. 2 times 6 minus 1. And I see that what is y going to equal? Well, y is going to equal 11. Now, this example gets used a lot, this style, in Unit 2 when we talk about equations of lines. You're going to see stuff like this all the time. So I need you not to panic. I need you to look at this and go, oh, it's just another example of evaluating. Looks a little weird. You could say, Kate, well, I really like your lazy cheat method. I want to use it here too to have my calculator do the substitution. That's fine. But it's super duper important that you know that you can't type that equal sign in your calculator. You can only either do the left-hand side expression or the right-hand side expression. Your calculator does not deal with equations. Your calculator deals with expressions. So one side at a time. So you could do it, but when you store that value of x, so we'll do 6 and we'll store it as x. Don't try to type in y equals 2x minus 1. Just put the expression part that has x in it. So 2x minus 1, and I can see that this whole thing comes to 11. I know that it's still equivalent because it was equivalent above, and I know to drop the left-hand side, the y, and I still get to y equals 11. So a lot of times students will ask me, how do you do this particular thing in your calculator? And I have to admit to them, well, your calculator doesn't do that part. Okay, so this is one of those. When you have an equation, you have to know how to drop down an equivalent equation because your calculator can only deal with an expression. All right, you guys, doing great, doing so good. Super proud of you. Happy learning.